talk to you about the least popular and the least understood object in the solar system. And no, I'm not talking about myself. I'm talking about Mercury. First of all, when was Mercury discovered? Well, the earliest records date back to Sumerians. But many other ancient cultures registered having observed Mercury with the naked eye, actually, during sunset or during sunrise. And so they name it differently. We call it Mercury thanks to the Romans. Another way to observe Mercury is during a transit. Mercury transits, observed from Earth. Mercury transits are very often, compared to others like Venus, for instance. They happen every 13 to 14 times per century. The last transit was May 2016, and the next transit will be in November 2019, so stay tuned. And in case you were wondering how the last transit looked like, and if you're not sure if you're going to be here for next year, so here I made an illustration of how that looked like, if you were very curious about it. It's crazy, it looks almost like the guy from Queen. Yes. So the first encounter of the Mercury kind was done by Mariner 10 during the 70s. The second one was by Messenger. Both were missions, NASA missions, which main objective was to study the environment of Mercury. So I want to talk a bit about what we learned from these missions. There are many cool things we learned, and also many open questions or mysteries to be solved still. That's weird. So among the most fascinating discoveries in the history of planetary exploration is finding ice deposits close to the poles of Mercury. So a combination of Mercury's very slow rotation and the orientation created these small regions, well, not very small compared to the rest of the planet, yes, but created these regions ought to be cold enough to form and leave ice there for billions of years. So this is one of the most amazing things that people didn't expect. Other very interesting finding, I found this one very cool, it's the not so sleepy hollows. These are structures that are akin to skin holes that have very sharp edges, as these ones here, that were not formed by impact. So they look like craters, but they are not. They were not formed by impact, so we can see how they actually change in very fast. And the thing is that scientists believe that these regions are evaporating volatiles very rapidly, so they form some sort of hole. So they evaporate volatiles to the exosphere. And still we don't know how they are formed or why they are there, etc. Other interesting finding is the hard-core interior. So apparently Mercury has a very hard core, as I said. It takes up to 75% of the planet radius. It has more iron in it than any other planet in the solar system. And scientists are not sure how we can form this, so it doesn't fit any solar system model so far. So that's kind of a question to answer. It also, Mariner 10 already detected magnetic field, something that was also not to be expected because it's so small and close to the sun. But it has a magnetic field. And the puzzling part about this magnetic field is that it's offset more or less 300 kilometers north. And people is wondering why. This is still something that has to be understood. And what else? Oh, it has extreme temperatures. So as Remo said, Mercury has its tidally locked. So it rotates 1.5 times every Mercury year, or 3 times every 2 Mercury years. So it, yeah, one part of it is facing the sun for a long time. So on the dark side, you will have regions that reach.
Bingo.
So these regions reach more or less minus 170 degrees Celsius. Is what they say first? Yeah, degrees Celsius. And on the day side, you can reach up to 400 degrees Celsius. That's really crazy. So, what else? Oh, Messenger also found a very big crater. It's called Caloric Spacing. So Mercury is a survivor of a very big impact. Scientists calculated that this asteroid that collided with Mercury must have had 100 kilometers diameter, so it's quite big. And using different filters from Messenger cameras, you can see the different compositions. So this spacing is mainly. It's a good source of sodium and potassium, for instance. Oh wow, yeah, Mercury also has a tail, like if it was a comet or something like that. It has, especially, it's very famous, the sodium tail. People still don't understand how this sodium tail is formed, so, but it definitely has to deal with some mechanism combining the interaction between the solar wind and the magnetosphere, but it's still in mystery. Other interesting fact is the gravity anomalies. So Mercury, here is wrong button. Superposed here, I put a Mercury's magnetic field. Where am I? Yeah, gravitational anomalies. Yeah. So shown in red here, we have regions where gravity is higher. So this in turn means that there are regions that have higher density. So it's still not understood why where did this come from? Probably from its formation or this big impact from an asteroid. What else? Oh, the last one, which is really cool. Well, maybe it's not the last one. It's shrinking. This is also crazy. So, don't ask me about this because this is very from geologist's point of view, but they have seen pictures in visible and a combination of other wavelengths, and they have determined that Mercury is shrinking. So this might give us a clue that Mercury was bigger, and it started shrinking as it cooled down. And these pictures haven't been seen in any other object in the solar system, so that's also cool. What else? Oh, Mercury is a chemical liquid. So there's something really weird about Mercury is that, well, that the chemistry is simply wrong. So scientists already knew before Messenger that Mercury has a density, it's only the second after Earth, so it's a very dense planet. And because it's so close to the sun, they thought that they would find mostly heavy metals on the surface, and you would expect that most of the volatile elements would evaporate and just go away because it's so close and hot, close to the sun and hot. So, but Messenger findings actually reveal the opposite. So we found almost no. Well, the iron content is much less than expected, and there's a lot of volatile content. And I actually worked on trying to understand how, where does these volatiles come from, and what is the dynamics between the surface and the exosphere. So, to solve all these mysteries, we have a future mission. That's Baby Colombo. If you didn't know about it, this is a mission that will be launched finally this year, after more than 16 years of delay. Yeah, thanks to that I have a PhD. Yeah, it will be launched in October 2018.
Bingo, bingo, bingo.
Okay, the bingo, yes. It will arrive in 2026. And it's a collaboration between, well, the European Space Agency and the Japanese Space Agency, the JAXA.
Bingo.
So Baby Colombo it's going to do more things that one Messenger or Mariner 10 did. For a start, it will boost two spacecraft. Oh, here. One called the MMO, which is the Mercury magnetospheric orbiter. Yes. And the Mercury planetary orbiter. So these two will focus on different things. So the Mercury magnetospheric orbiter will focus mainly on measuring magnetospheric data. And the other one will be much more focused on geology and studying the surface and the exosphere. Oh, I didn't mention that, but the University of Bern is very closely related to this mission. So they design and build part of two instruments. One of them is VELA, which is a laser altimeter that will characterize and measure the figure, topography, and surface morphology of Mercury. And the other one is Astronomy, which part of it was also designed and built in the University of Bern. And this is the project I'm working on. So Strofio is a mass spectrometer that will measure for the first time, will do in situ measurements of the exosphere compared to the other two missions that was made before. Whoa! Okay, I'm stopping. What else? Oh, yeah, so I'm going into the summary. So in summary, and to best compare Mercury to someone that you will never forget, and also with the risk of you going out of here after I talk. In short, Mercury is just like a grandma. Heavy metal grandma. Why? Because it has a heavy metal core, although maybe into grayscale. It has wrinkles, and well, it's also kind of shrinking. Also, it rotates very slowly. It also, of course, has a magnetic field. Well, if you were wondering how the next transit will look like, if you're not sure, you will be sure next year. It will look like this.